This is our first lesson in Chemistry 1, Introduction to Matter. In this lesson, we are going to define matter, identify and differentiate the three states of matter, relate the basic properties of each state to their particle model, and identify properties as either physical or chemical, intensive or extensive. In this first part of the video, we will first begin by uh, defining what chemistry is. Of course, chemistry is one of the fields in science. Other fields in science are biology and earth science. Biology is the study of life, earth science is the study of the earth. So their definitions are simple and direct. So from these definitions, it's already very obvious what these subjects will be all about. But for chemistry, we have this definition. Chemistry is the study of matter. So we have this not very familiar term. And of course, if we want to understand chemistry, we must first understand what matter is. So what is matter? By definition, matter is anything that has mass and occupies space. Now, what are the things that has mass and occupy space? Let us consider this rock. Of course, rocks are heavy, so they obviously have mass, and rocks occupy space. So of course, if you put this rock on a basket, for example, so obviously this rock will occupy space inside the basket. So this rock is obviously a form of matter. Again, a matter must have first, must have mass, and second, it must occupy space. Next, let's assume there are ghosts. Let's say this ghost tries to weigh itself. Of course, the readings would be 0 grams because ghosts have no mass, so they don't have mass. Also, if this ghost tries to dive in water, of course, nothing will happen on water because this ghost does not occupy space. So this ghost is not a form of matter. Now let's go back to reality and try to find out things that has mass and occupy space. Your phone, of course, your phone is heavy, it has mass, and it occupies space. So your phone is an example of matter. How about your laptop? Your pen, your ball pen and pencil, also your notebook and your paper, these are all examples of matter. We also have volcanoes. Of course, volcanoes are very big. They occupy large amount of space, and also they are made up of rocks, which is very heavy. Next, we also have water. The water also is heavy, and also it occupies space. The air is also a form of matter, even though it's very light, it still have mass, and it obviously occupies space. We also have the sun. The sun, of course, is the heaviest object in the solar system, and then it occupies large amount of space. It's actually the biggest object in the solar system. We also have the moon. So the moon is also made up of matter. We also have other planets in the solar system and other galaxies. We also have stars. We also have asteroids, comets, and also plants. They are also is made up of matter. We also have other animals and other living organisms. So as you observe here, we are surrounded by matter. So most of the things that you see are forms of matter. And we also refer to these things as simply materials or objects. Materials or object. I cannot click that. Materials or objects. So we can say that matter is the same with the word material, materials or objects. And so here by this we can make a simpler definition of chemistry. That is, chemistry is the study of materials or objects around us. And also our body is also made up of matter. Of course, our body has mass and it occupies space. Now again, most of the things around us are made up of matter, but is everything around us made up of matter? Because some people define chemistry as the study of everything. Is this definition correct? Because here they assume that everything around us is made up of matter. Of course, when we say everything, we are referring to the universe because the universe is everything that exists. And of course, when we think of the universe, we think of the sun, the moon, planets, stars, planets, and the asteroids, comets, and all the objects. And again, these are all forms of matter. But aside from matter, the universe is also made up of energy. Example of energy is light. So light is not made up of matter, it's actually a form of energy. Aside from energy, we have space and also we have time. So again, this is everything. This is the universe. So the universe is simply everything that exists. But again, in chemistry, we will not discuss everything here. We will just focus on one component of the universe, which is the materials or objects in the universe. So that is what is chemistry is all about. Chemistry is the study of matter, and again by matter we refer to this as anything that has mass and occupies space. So basically these are the objects or materials you see every day. So let's talk more about matter because that's what is chemistry all about. So chemistry is the study of matter. So we'll discuss more about matter. So first we can categorize matter into three different states or three different phases. So again, this is called as phases or states. And again, we have three different states or three different phases. These are solid, liquid, and gas. Solid as in this solid gold bar, liquid as in this liquid water in this glass, and the gas as in the gas inside this balloon. So these are the three phases or states of matter, and of course we categorize them or we differentiate them because they have different properties or characteristics. Let us start with their shape. Of course, for solid, their shape are constant, meaning their shape is fixed. Because example, if you put this gold bar in a boxy container, it will retain its shape. So it will still have this same shape. So again, for solids, their shapes are constant. That's different for liquids because if you transfer this liquid to this container, obviously its shape will change. So in this case, its shape is like cylindrical because that's the shape of the container. But if you put this on another container, of course, it will change its shape. So we can say that for liquids, their shapes are not constant. So liquids have no constant shapes. And the same for gases. Obviously, the shapes of gases are very flexible. They also depends, its shape also depends on the container. So for gases, the same thing for liquids, no constant shape. Now let's talk about volume. So volume is the space occupied. Okay, volume is the space occupied. For example, here we have ball A and we have ball B. So which of the following balls has larger volume? So it's obviously ball B because here ball B occupies more space. And again, this space that is occupied, we call this as the volume of the object. Now let's identify whether the volumes of solids, liquids, and gas are constant. So for solids and liquids, it's obviously constant. Okay, it's constant, constant. The same thing for liquids, it's also constant. But for gases, as we know, gases can either expand, so they can increase their volume, and also they can be compressed into smaller spaces. So again, gas don't have constant volume, no constant volume. So that's it. So in summary, again, for solids, they have constant shape and constant volume. For liquids, they have constant volume, but they have no constant shape, meaning their shapes are flexible. So they can flow and change their shape depending on the container. And then for gases, they have no constant shape and no constant volume. Again, no constant shape because they can change their shape depending on the container, and for volume, obviously gas can expand or be compressed into smaller spaces. And now let's look on their particle models. So their particle models can help us um, understand more of their properties. So again, for solids, the shape is constant. This one is not constant, and this one is obvious. Oh wait, let's go to the next one. Okay, here we have um, the summary of the shape and volume of solids, liquids, and gas. Next, we'll try to compare their particle models. Let's compare them first in terms of their distance, the distance between the particles. Okay, distance between the particles. So obviously for solids, here the particles are very close to each other. And for liquids, it's also close, so they are still close, but not that close compared to solids. And also, there's a difference because for liquids, the particles can still move around each other, so they have freedom to move around. While for solids, since again they are very close, they are also these particles also cannot move. So these particles are stuck on their places. And let's go to gases. So for gases, obviously here, the particles are far apart from each other. So far apart from each other. Next, what's the reason behind this? Why are the particles of solids very close to each other, and why are the particles of gases far apart from each other? Again, that's because of the forces between the particles. So there are forces between the particles, and these forces can be strong or weak. And again, these forces, by the way, these are attractive forces. So these forces attracts these particles together. So for this solid, obviously, since the particles are very close to each other, the force must be very strong. That's why the particles are close to each other. And for liquids, the force between the particles are also strong, but not that strong compared to the forces in solids. And for gases, the attractive forces between the particles must be very weak. So these are the differences between the particle models of solids, liquids, and gases.